Assalamualaikum and good evening. My name is Muhammad Amin and I'll be presenting introduction for this group titled Passive Low Pass Filter. And our team members is me, myself, Muhammad Amin bin Jalani, B0821103112, Muhammad Haizat bin Mustafa, B0821102022, Muhammad Syauqi bin Ramli, B0821101129, Muhammad Syafizah Haikal bin Samsudin, B0821100257. Introduction to passive low pass filter. A passive low pass filter is a type of low pass filter that is made up of passive electronic components such as resistor, capacitor, and inductor. The gain of a passive low pass filter is always less than or equal to 1, so its output signal amplitude is always less than its input signal amplitude. Low pass filter, or short form LPF, is a type of filter that allow low frequency signal and block high frequency signal. The frequency lower than the selected frequency, known as cut-off frequency, are passed, while any frequency higher than cut-off frequency is blocked by the filter. There are two types of low pass filter, which is the passive low pass filter or the active low pass filter. But in this report, we will only discuss about passive low pass filter. First order low pass filter. First order low pass filter is the simplest form of the pass filter that are made of only one reactive component, which is capacitor or inductor. A resistor is used with the capacitor or inductor to form RC or RS passive low pass filter respectively. RC low pass filter or RL low pass filter. RC low pass filter. The simplest passive low pass filter is made up of a resistor connected in a series with a capacitor, and the output is taken across the capacitor as shown in the figure below. As we can see, this is where the input, while this is our resistor connected to capacitor, and this circuit will form into RC low pass filter. Frequency response. The frequency response, also known as Bok plot of a circuit, shows the output to input ratio for a specific frequency range. The frequency response of low pass filter is given below. After the frequency response, we can also get cut-off frequency. Cut-off frequency, also known as FC, is the selected frequency point where the output signal power becomes negative 3 dB or 70.7% of the input signal. At this frequency, the capacitive reactance at C and resistor reactance R become equal. The cut-off frequency is calculated by, which is the formula R equal to FC and R equal to 1 over 2 pi FC, or FC equal to 1 over 2 pi RC. And finally, this is all that we can get from the Bok plot and all the filtering as the result. Pass band, stop band, bandwidth, and roll off. Pass band is the range of the frequency that gets passed through the filter. In the low pass filter, the pass band frequency is lower than the cut-off frequency FC, while stop band is the range of frequency which is blocked by the filter. In low pass filter, the range of frequency higher than the cut-off frequency FC is referred to as stop band. Bandwidth. The bandwidth of the filter is a range of frequency that gets passed without any intuition. The low pass filter allows frequency from 0 Hz to frequency cut-off Hz, so its bandwidth is FC minus 0 equal to FC Hz. Roll off. When the frequency increase and reach the cut-off frequency, the gain of the filter start to decrease. The rate of the decrease is the gain is known as roll off.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Muhammad Syauqi bin Ramli. So today I will present about procedure for this low pass filter RC. So the first procedure is the transfer function. TF for RC low pass filter of the circuit can be determined using the formula of TF equal to 1 over 1 plus J omega over pi A over P. So P equal to 1 over RC. So the second procedure is to cut off the frequency for the circuit. We can determine using the omega C equal to 1 over RC, and for the frequency cut off we can determine using the calculation 1 over 2 pi RC. The third step For this procedure is we build a circuit containing of 0.47 microfarad capacitor and 330 ohm resistor. Then for the function gen as a power input and the oscilloscope as an output result for our circuit. The next step is assemble the circuit, then connect oscilloscope for channel 1 to the input voltage as a V in and adjust V in to voltage in to have an amplitude of 2.0 Vp, which is 4.0 V peak to peak at a frequency of 100 Hz on the oscilloscope display. And the next step is connect oscilloscope for channel 2 at the across the capacitor for measure the voltage output and shift of phase angle for the output voltage. And the last step is for this procedure is to increase the frequency of the function gen to the frequency indicate 200 Hz, 300 Hz, 500 Hz, and 800 Hz, and 1000 Hz. And if it's necessary, adjust the amplitude of the function gen to ensure that voltage in is maintained at 2.0 Vp on the oscilloscope display. Then we measure the amplitude and shift of phase angle for voltage out for each frequency.
Hi, my name is Muhammad Haikal, and this is result for simulation. First, we start at 100 Hz, and at the oscilloscope we can find the V out and also shift of phase angle. For the 100 Hz, we get 1.92 volt for V out and also negative 5.04 degree shift of phase angle. For AV, V out over V in, which is 1.92 divided by 2 and get 0.96, and for the next voltage gain in the decibel dB, we can get using the formula 20 log V out over V in. And then the simulation continue with different frequency, which is 200 Hz, 400 Hz, 800 Hz, and the last 1 kilohertz. Next is to find the cutoff frequency. We need to multiply 0.707 with Vmax, which is 1.92 volt, and get 1.357 volt. And next, adjust the frequency at function gen until the oscilloscope at channel 2 show 1.357 volt, and then we get the cutoff frequency at function gen.
Assalamualaikum. My name is Muhammad Haizat bin Mustafa. Discussion. In discussion, the main thing that we have been learned in about a low pass filter is a filter which pass low frequency signal and block or impedance high frequency signal. In other words, low frequency signal go through much easy with less resistance, and high frequency signal have a much harder getting through, which is why it is a low pass filter. The cut-off frequency of the low-pass filter indicates the frequency region in which the filter is transitioning from low altitude to significant altitude. Then, when we calculate the cut-off frequency, it is easy to compare the value with a measure. The concept of phase refers to the value of the periodic signal at a specific moment with a cycle. Okay. In low-pass RC filter, the a capacitor is a reactive device which offers very high resistance to low frequency or DC signal, and it offers low resistance to high frequency signal. It is offer very high resistance to DC signal. In this circuit, it will block DC from the entry and pass them off an alternative path in the circuit, which is shown to the right by the arrow. In low-pass RC filter, inductive resistance is how the impedance or resistance of the inductor changes based on the frequency of the signal passing through the inductor. Unlike a resistor, which is not reactive device, and inductor offer differing impedance value to signal all the varying frequency just add a capacity to. In conclusion, the transfer function and cut-off frequency for a low-pass filter is determined by using a formula. The frequency response of low-pass filter circuit also can be determined using straight line from the board plot. The value of Fc can be determined by using V of equal to 0.707 Vmax. The output voltage of an RC low-pass filter can be calculated by tracking the circuit as a voltage divider consisting of the frequency impedance resistance and a frequency-dependent reactance. To increase the cut-off frequency of RC circuit, we need decrease the resistor and capacitor value. The output from the filter circuit will be alternate depending on the frequency of the input signal.